Hello everyone, I am Dr. Naurang Manik Rao. Title Calculus of Residues, Program BSc, Subject Mathematics, Semester 5th Semester, Paper Complex Analysis, University Gulbarga, University Kalaburagi, Session 50. Unit 4, Calculus of Residues, Computation of Residue. Recapitulation. In the previous classes, we have studied about types of functions. In this semester, we are going to learn computation of residue. Learning objectives. Students to gain the knowledge of computation of residue. Outcome. Students will get ideas of how to compute the residue easily. Computation of residue at infinity. The residue of f of z at z equal to infinity is 1 divided by 2 pi I integration over c1 f of z dz taken in clockwise direction round a large circle c1 which encloses all other singularities. Therefore, the residue of f of 1 by w at w equals 0 is given by, on putting z equal to 1 by w, 1 divided by 2 pi I integration over c f of 1 by w into minus 1 by w square dw, and that is equals to 1 by 2 pi I integration over c minus 1 by w square into f of 1 by w dw taken in the anti-clockwise direction around a small circle C with center at origin. Note the distinction between C1 and C. Hence, the residue of f of z at z equal to infinity is limit w tends to 0 bracket minus w into f of 1 by w whole divided by w square. So that is equals to limit as z tends to 0 bracket minus z into f of z. Special case. Suppose f of z has a pole of order m at z equals to infinity. Then f of 1 by w has a pole of order m at w equals to 0. Therefore, by Lorentz series, f of 1 by w equals summation n equals 0 to infinity an into w power n plus summation n equals to 1 to infinity bn divided by w power n. Therefore, the expansion of f of z has a pole of order m at z equals to infinity is f of z equals summation n equal to 1 to m bn z power n plus summation n equal to 0 to infinity an into z power minus n. Now, integration over c f of z dz equals integration over closed curve c summation n equal to 1 to infinity bn into z power n dz plus summation n equal to 0 to infinity integration over closed curve c an into z power minus n dz, and that is equals to integration over closed curve c a1 divided by z into dz. All other integrals vanish since each of them is of the form integration over c dz divided by z power k, where k not equals to 1. That is equal to a1 into 2 pi I. Hence, the residue at infinity is equals to minus 1 by 2 pi I integration over the closed curve c f of z dz. That is equals to minus a1, where a1 is the coefficient of 1 by z in the expansion of f of z in the neighborhood of z equals to infinity.